So previously we just had to complete in section A, which is just filling out this table. So once we kind of put in all information here and here, we can just fill out our information and we can get our U value. Okay. For 2025 or 2022 or 21, whatever this exam was done, you actually got the majority of your marks just by simply creating that first table. Next thing is going to be a caloric value of oil. Okay. So what we're trying to do is work out how much heat or how much money it's going to cost us to heat the house or heat one room, how much of that's going to go out through the wall. Okay, so we can't have any kind of insulation or anything that will prevent total heat loss, right? It's pretty much impossible. So what we can do is kind of calculate how much we kind of see as an allowance. Okay, so in this case we have a wall. So the area of the wall is 144 meters, right? U value itself only kind of gives us a general term, right? So watts per meter squared degrees Celsius, okay? What that means is that's only kind of telling us how much heat goes out through a wall and kind of the rate of which the heat goes out through a wall in a given second, okay? So what we have to do is, you see it's there meter squared, down here meter squared. So what we first have to do is calculate the heat loss, okay? So we have to see, obviously label everything as well. So we have to first see the heat loss, okay? So to do that, we use our U value, in this case 0.191, okay? What we then do is we multiply that by our area. So if this is just given in one kind of meter, kind of one individual singular spot, this is the total size that's going out through, okay? What we then have to look at is what's called a temperature difference, which is over in this side. In this case, it's 20 minus 5, which is going to be 15. Now, what that means is that if inside is generally about 20 degrees and outside is about 5 degrees, the heat will naturally want to go outside. Okay? What this comes into effect is when we're trying to calculate it, obviously the warmer it is outside, but the colder it is, warmer it is inside, but colder it is outside, the heat will actually leave the house at a much faster rate. So this is what this is calculating. So what this actually works out to then, 0.191 multiplied by 144 times 15, that's going to work out to 412.56 joules, which is a form of energy per second. So that per second part is crucial, okay? So next then is heating period, okay? So this is how long we actually turn, say, our oil or our gas on for, okay? So it says down here, our heating period is 10 hours daily. That means 7 days a week for 37 weeks. Okay, so we are talking about seconds. So if we break it down into, there's 60 seconds in a minute, there's 60 minutes in an hour. So now I've worked out my seconds. So 60 seconds for 60 minutes for 10 hours. Okay, for 7 days a week for 37 weeks. Okay, I'll go through that again. Seconds, minutes, hours, days, weeks. Seconds, minutes, hours, days, weeks. Right? That breaks down how much kind of time is elapsed in terms of seconds. So, quite simply multiplying that out, we will get a very large number. So in this case, that large number is going to be 9324000. So 9,324,000. Okay. So now I can work out the total joules that, or total energy that is lost through the wall. Okay. Now, like what we can do in kilometers and meters, so we can also change this into kilojoules. So like meters go to kilometers, joules can go to kilojoules. Okay. So part 3 then is quite simply multiplying these two figures, dividing by 1,000. So 412.56. So divide it all by 1,000 and I'm getting a 384670.44 kilojoules. Okay, so that's how much energy that is lost through a wall in that given year period. Okay, what we then just have to do is figure out how many liters we use and then how much that costs us. Okay, so liters is very, very simple. It's going to be this number, so 384670.44 caloric value of oil. So this is how much energy you get out from 1 liter of oil. Okay, so that's what's found on here. So going back again, going between your workings back to your question. So over here we're looking at the caloric value of oil. So that's how much energy is generated from 1 liter of oil. So if we're generating 37,350, that figure never changes. Never. This figure does. So if that's how much energy we used, that's how much energy we get out from 1 liter. What we can simply do is divide it in, so I'm getting 102.99 liters. So it's cost me 103 liters, let's say, of oil in a year. How much is that going to cost me financially? I look in the question. Cost of oil, 97 cents. So 102.99 times 0.97, as in 97 cent is 0.97 euros, equals, I am getting, it's going to cost, give or take, 99.90 a year. And that is just pure loss. So all that money, so 100 euro worth of heat, 100 euro is pretty much going straight out the wall, out into the environment. We can't do anything about it. That is how much heat we have lost throughout the year.